I'm Dalton Reither, and we are Group 12. This is our project for senior design in the Industrial Manufacturing Engineering Department at Iowa State University during the spring of 2021. We worked with a sheet metal design company that has been experiencing an ongoing issue with trim bruising on their final products that require crimping process to secure them. The current crimping tool uses the force applied to the back of the trim at an angle with respect to its face. The tool applies force at the acute point and uses a metal face or metal front face to make contact with the trim's visible face.
Hi, I am Jesse, and I will talk about our objectives and our original design. So our objectives for this project was to design and propose a tool head to be used during the crimping process that could eliminate bruising from the metal, saving $49,000 in reworked material cost. Our initial design intent was to distribute the load of the force applied to trim over a significantly larger area and at a different location. To do this, a small triangle-shaped piece was machined to our specifications and secured to a handheld base tool with countersunk screws.
I'm Grant Herrera, and I'll be talking about the discovery, future state, as well as the tool modifications. Initially, we found this design to satisfy the objective. The trim was crimped securely in place, and there was no visible bruising on the trim's face. During testing, when we pulled a piece of crimped trim off, our assumption that the triangle piece was the primary method of applying the force was falsified. The screws intended to hold the angular piece to the base tool were actually applied the pressure. The trim's backside is shown here in the image to the right. Tool modifications. Using the principles discovered, we came up with 3 different designs to rigorously test to determine their effectiveness. The first design is a current state design, which aimed to mirror the crimping currently taking place during production. The second and third designs utilized those protruding screws that had previously been doing the crimping to apply force to the trim's backside. All 3 tools used a plastic front piece with curvature matching the profile of the trim. Our company currently uses a metal front piece, so all of our tools differ in that regard.
Hi, I'm Nick Eggers. To test our solutions, we built a fixture that Dr. Stone said would stop a horse. The fixture was designed to securely hold material in place during the crimping process, and it held the pieces at a similar height to the one used during production. After rigorous testing, the group saw bruising on only one sample that utilized the current state design. This indicated that the other 2 designs satisfy the project's objectives. Possible reasons for success include rounded screw heads, the angled back face, the plastic front face, and force applied perpendicular to the trim's front face. The economic opportunity for this project includes costs of experimental material consumption, tool purchases, tool modifications, pneumatic tool construction, and operator training, and has estimated annual savings of $49,000 per year.